Hello viewers, welcome to Trinity Software. Let's see about the queue data structure and its implementation in Python in this video. Here is a real life example for queue. People are standing in a queue at the bank counter. The person who is in the front of the queue will get the service first, and after getting the service, he or she will be leaving the queue first, and the person who wants to join the queue will join at the back end called rear. Queue is also a linear data structure. In the linear data structure, the elements are arranged in a sequential manner. Other examples for linear data structure are list, stack, and array. Each element is connected to its previous and next elements. One end is always used to insert the data, and the other end is used to remove the data. And queue follows first in first out methodology. That is, the element stored first will be accessed first. So that is the concept of first in first out. The two major operations involved in queue are enqueue and dequeue. Enqueue means to insert an element into the back of the queue, also called as the rear end of the queue. Dequeue means removing the element from the front end. And peek means we are just returning the front element of the queue. If we just want to know which element is present at the front, we can use this peek operation. This is about enqueue operation. Taking our real life example, 5 people are standing in the queue and a 6th person is trying to enter the queue. So this operation is called enqueue, meaning we are going to insert a person into the rear end of the queue. After insertion, this rear will be pointing to the latest element added. In this case, the last person added to the queue. So rear always points to the end of the queue. Considering the dequeue operation, dequeue will remove the element from the front. Front will be pointing to the beginning of the queue. So dequeue operation will be done with this person. After dequeue, the second person will be moved to the first position now. This is how dequeue operation is performed. So the difference between the stack and queue is in this dequeue operation. In a stack, we remove the item the most recently added, whereas in a queue, we remove the item the least recently added. Okay, let's see the applications of queue in computer science. Queue is used in serving requests on a single shared resource like a printer or CPU scheduling. Considering a printer, the jobs will be printed in the order of their arrival. And actually there can be a multi-user, multi-programming and time-sharing environments. In these environments, a computer can handle several jobs at a time by using this concept of queue. Now let's see the implementation of queue using list in Python. In the previous video, I have explained about the implementation of stack using list. So I have made a slight modification to that stack program for queue. Actually, in queue, we are performing insertion at one end and deletion at the other end, whereas in stack, we performed insertion and deletion from the same end. So this push operation is replaced by enqueue and pop operation is replaced by the function dequeue, and we have one more function called peek, and we are having the same menu driven program to display all the choices to the user. Okay. The minor change which has been done in the stack program is that this dequeue operation will be done from the front end. So we are using this pop function by passing an argument as 0. Whereas in stack we will just pop the topmost element. Here we are going to pop the element present at index 0. So you have to mention pop of 0 here. Other conditions all remains the same. We are appending the element to the end of the queue using append method, and we are checking if queue is empty. We cannot perform dequeue operation, else you can perform dequeue operation. Peek is just going to return the front element of the queue, and for that purpose also I am checking the condition whether queue is empty or not. Okay, and then initialize to the queue to an empty list, and we have these options left to the user. The user can choose what to perform with the queue. So now let's run this program. we have 5 options. I will just use enqueue operation and I will insert 10, one more element 20, 30, and we will list out the queue. So 3 elements are present in the queue. If you are trying to dequeue an element, 10 is dequeued from the queue first, then 20 is dequeued, and you can check what is the element present at the front of the queue. This is going to be just 30. So 30 is the front element of the queue. Even if we display the queue, only 30 will be present. We are going to dequeue this also, and if you are trying to dequeue once again, you will get the message stating that queue is empty. That's it. Now I can add one more condition to this. I can fix the maximum size of the queue. So that option is available. In this case, we can fix the maximum size of the queue as 5. So it means that the queue can accept only 5 elements at a time. You cannot append or insert a 6th element into the queue. If already 5 elements are present, you cannot append one more element to the queue. So that condition can be checked here. When the user chooses the option enqueue element to the queue, we can check a condition like if the length of the queue has reached the maximum size. In that case, we cannot enqueue an element. So that condition can be given here. In that case, I am just printing queue is full. Else, if the length of the queue has not reached the maximum size, in that case we can get the item to be inserted to the queue, and we can call this function enqueue, queue comma item. Now we'll check this. So I have fixed the maximum size as 5. I will insert 5 elements. So totally 5 elements are present, and if I am trying to insert one more element, after checking the condition, it gives the message that queue is full, so we cannot append an element to it right now. At the same time, you can delete an element, and now you can insert an element. That is possible. That is about the queue implementation in Python using list. In considering the time complexity, lists are actually not efficient for this purpose, and this append method and pop method works fast from the end of the list, but doing insertion or pops from the beginning of the list is actually slow because all the other elements have to be shifted by 1. So in this case, dequeue operation time complexity is order of n, whereas enqueue operation we are appending at the end, so it will remain order of 1. So for an efficient implementation of queue, we can make use of collections.deque. Deque stands for double-ended queue, and it is implemented with the doubly linked list. We can use the pop left method to perform this dequeue operation efficiently in order of 1 time complexity. So this deque is designed to have fast appends and pops from both the ends, and it supports memory efficient appends and pops from either side of the deque. And it has many methods. For insertion, we are going to use append method, add x to the right side of the deque, and for deletion we will use pop left method. It will remove and return an element from the left side of the deque. In case if there is no element present in the queue, it will raise an index error stating that you are trying to pop from an empty deque. Let's implement the queue using this deque. From collections, we'll import deque. Now we'll initialize the queue. It's going to be an empty one. Now we'll add elements to this queue using this append method, queue.append. I'll just add some string. Python we'll just use the print statement and find out what is present in the queue. So we have got 3 elements in the queue: dequeue, Java, Python and R. If you want to delete an element, you can use pop left method. Queue dot pop left method, and you can check it out. So after popping the leftmost element, actually it's in the order Java, Python, or the front element is deleted according to the concept of queue, and the remaining 2 elements Python and R are present in the queue. So this is how an efficient implementation of queue is done using this deque from collections. So the time complexity of both enqueue operation and dequeue operation remains the same. It is order of 1. That's it about queue data structure and its implementation in Python. Thanks for watching. Kindly subscribe for more videos on programming concepts.